significant figures. You'll have been taught about these in maths. You'll have been asked to round to a certain number of significant figures, and you'll have been asked to identify the number of significant figures that you have in certain values. That skill is really important in physics and many of the other STEM subjects as well. And in this little video we're going to see how important the application of significant figures is. We'll do that with a little experiment demonstration where we measure the average speed of a cart as it goes down a ramp, and we'll have a look at a couple of problems where it's important to choose the correct number of significant figures to give your answer to. To set up this little experiment, I've got a ramp. I've got some old video cases to prop up the ramp and a meter stick to measure distance, and I'm just going to use a mobile phone to measure time. So in the experiment we used the stop clock in order to measure the time, and that measured to the nearest 100th of a second. So our time measurement was 3 significant figures. Our distance measurement was to the nearest centimetre, and so 1.00 metres is also 3 significant figures. Therefore, when we work out the average speed of the car, we can answer to 3 significant figures. Any more than that we cannot claim, because the measurements that led to that calculation only had 3 significant figures in them. So we cannot claim an answer which has more than 3 significant figures. The results from the experiment are shown here. So we have our time measurement of 2.04 seconds and our distance measurement of 1.00 meters. We have 3 significant figures in each here. The 2 is significant, the 0 is significant because it comes after a number, after a decimal point, and the 4 is significant. And similarly here, the 1, the 0 and the 0 are significant. So 3 significant figures in each. To work out the average speed, we're going to use the equation for speed. Speed is equal to distance divided by time. And when we substitute in here, the speed is equal to the distance, 1.00 meters, divided by the time, 2.04 seconds. And I put that on a calculator, and the result that I get is 0.4901960784. Now clearly, it would not be sensible to express our answer to that number of significant figures. Going back to the question, I can see that I have 3 significant figures, so I'm going to round my answer here to 3 significant figures. So the 4 is significant, the 9 is significant, and so is that 0. Therefore, my end result will be V is equal to 0.490 meters per second. Here we have another worked example of using speed, distance and time to illustrate significant figures. And we have an athlete that's going to run a distance of 100 meters, that'll be the 100 meter race, and he has managed that in a time of 9.93 seconds. We're asked to calculate the average speed of the athlete, which will come using the equation for speed is distance divided by time, so V equals D over T. And we substitute into this equation, V is equal to 100 meters divided by the time, 9.93 3 seconds. Now, if we look at the significant figures, we can see there are 4 significant figures in distance here and 3 significant figures in time. So 4 significant figures, 3 significant figures. And when we have a problem with a multiplication or division, we must give our final answer to the least number of significant figures in the question. So that would be 3 significant figures that we answer to. On a calculator, V comes out as 10.0705. To round this to 3 significant figures, the 1 and the 0 here are significant, as is the 0 after the decimal point. So there's our 3 significant figures here. The 7 that follows the 0 will round this up to a 1. Therefore, our overall answer will be V is equal to 10.1 meters per second.